My idea was very simple.
A low-level language to manipulate hardware.
And something called Simula.
A lot of people did not think that C++ was right.
I look at C++ and I find it scary.
It underlies many of the biggest systems in the world.
If you make a small incompatible change, you can annoy a couple of 100,000 people.
The C++ is controlled by a committee.
C++ feels like a new language.
And they may look at C++ and they say, why?
C++ is more than 40 years old.
The world was very different from today. In a way, a much simpler world. In many ways, a more exciting world. There was a lot of stuff that did not exist and was just beginning.
We just simply cannot write all the software that needs to be written.
Colorization, syntax highlighting, code navigation, statement completion, refactorings, none of that stuff existed back then. Some machines only had like line-oriented editors, so if you want to modify something in a line, you had to retype the whole line. It was just really primitive.
A lot of people programmed in BASIC, but to do anything really advanced, you had to program in assembly language. And that assembly language is different for every different kind of chip that each computer had.
Eventually, computers evolved to what we have now, this sequence of bytes.
With an 18-bit address, the system can accommodate 256K bytes.
There was a need for larger and more complex programs, so new languages appeared. And in that milieu came C++.
Hello. I'm Bjarne Stroustrup.
As a language that promised great abstraction on top of a very efficient bed set by the C language.
C++ did not become as this one perfect thing coming out of Bjarne's mind. It started as a very small thing called C with classes.
At Bell Labs, about 50% of the people are actually producing software.
Bjarne probably arrived in roughly 1979 or 80, I don't remember exactly. I didn't know a lot about his background, except that he'd come from Cambridge.
I don't know what the Queen is doing there, but this is a bunch of PhD students in Cambridge. I was at Cambridge and there was some contacts with Bell Labs. Some of the people from the computer lab in Cambridge had gone there. And one was back. At some point he said, well, if you need a job next year, give us a buzz. So I did. I flew over to the States. I was met by Sandy Fraser. And Sandy said, well, sit down, Bjarne. I've got some bad news. We don't have any jobs. I just crossed the Atlantic. Anyway, I gave a talk, then they changed their mind. And so I was there for the next 24 years.
Bell Labs was part of AT&T. At the time, AT&T was a very large company, probably the largest company in the country.
Almost 1 million people worked for Bell at some 27,000 different locations across the country. 3 out of 4 phones in the country are Bell.
And so that meant they had an essentially guaranteed revenue stream. They knew how much money they were going to have, and they peeled off a little tiny slice of that and used that to fund Bell Labs, whose job was to do things to improve telephone service.
Its job is to design and develop the products, systems, and services to keep communications purring.
I was astonished when I came to the United States. You could call from New York to California, and there was absolutely no noise on the line.
Because there were so many people, they could take a very, very broad view of what it meant to improve telephone service. So anything that somebody wanted to work on, arguably that was fine.
A lot of the textbooks were written by people from there. They built the C language, the Unix operating system, a lot of map drawing software, a lot of graphics software, chips that later became digital cameras. Everything was going on there.
It was the place to be, right, if you wanted to do anything in computing.
I felt I had to do something reasonably spectacular because that was what other people had been doing. And so I decided I was going to build a distributed system based on Unix. I set off trying to figure out how to separate the various services of the kernel into separate modules and to think about how users could talk to each other through this kind of stuff. I realized I couldn't write the code I wanted. because I needed to be able to manipulate the hardware. You have to write device drivers, network interfaces. You have to implement memory managers, processors, things like that. You needed a low-level language.
Along the way in the course of the Unix system's development, Dennis Ritchie created the C language.
C came out of the department at Bell Labs I was in. Dennis Ritchie and Brian Koenig was down the corridor. So C was the obvious one to pick.
It lets you avoid the details of the machine when you want to, but when you need to, you can control everything.
It was very well designed for system programming kinds of things, like writing the tools that themselves are used by programmers.
C was a very great language which fully described the machine.
One thing that C didn't do was make it really easy to control what was going on in a program as the program got big.
We developed software that was unbelievably big in terms of the number of users or the performance demands on it. You know, everybody in the country is picking up the phone. That's an AT&T program that you were talking to.
C was not, in some ways, an ideal tool for that.
For a distributed system, you really have to be able to say this piece of software talks to that piece of software over there. How does it talk to the other one? What protocols do you use? And where is it? You can't just have a rat's nest of pointers into memory because they will probably not share memory. So I needed a high-level language to be able to say, this is a module, this is a communication channel and such. In Aarhus and Cambridge, I'd used Simula, the original object-oriented programming language, and I really liked it. It had strong type safety, it had the ability to build your own types, classes, it had class hierarchies.
And so that gives you a way to take something that could be potentially very big, amorphous, unstructured thing and put a lot more order and structure on it.
It was also far too slow and used too many resources, too much memory. So I decided I was going to put the basic functionality from Simula into C. So that was why what I did was called C with classes. I spent the next almost 40 years trying to get to the point where C++ can do everything what Simula and C could do. That quest is probably what made C++ a success, because there was always a challenge.
Here we have an old picture of Bjarne and Christian Nygaard. Does it say Uppsala something?
I don't know. Do you have a digital version of it? Then you probably could.
I have a digital version somewhere.
Yeah. I didn't know you knew snowball.
Yes.
Hardly anybody knows the language.
Yeah. Oh, this was it. This is actually a paper carbon thing put up at a conference because Bjarne didn't attend in person. So they had some booths presenting C++ and then they had put this one up. You could go over there and they could take a picture of you and then they would make this thing.
Yeah. It's a cardboard copy of me.
And up here I have several of Bjarne's books also. He used to send me a copy whenever he wrote a book, but recently he hasn't done it.
Oh dear. I built C with classes as a preprocessor to C so that I could write the code I wanted. It was sort of a success. Other people started using it. Bjarne Stroustrup was working literally down the hall from me, and I knew vaguely that he was working on something that was trying to make C a more abstract language to program in. So I started learning that and talking to him about things he was working on in that area, and eventually we wound up working quite closely together for a number of years. So this is the Bell Labs building at Murray Hill, where Bjarne and I worked for quite a while. And now it's in the process of being cleared out. But it's where a lot of the early C++ work was done. And there were a bunch of real interesting characters. You put a lot of highly intelligent people together in one place and all kinds of things happen, some of which you can control, and others of which you can't. I realized one day that C with classes just wasn't a significant enough jump from C to be viable, that it was a medium kind of success and it would never be any more. I thought I had just two choices. I could drop C with classes or I could make it much better. So I spent a year building a compiler and improving the language the way you could only do if you have a compiler. So originally Bjarne just wrote CFront.
Instead of having a traditional backend that compiled down to machine code, it compiled to C code.
So if somebody wanted to use C++, they didn't have to buy into a whole new way of doing business. They didn't have to buy into a whole infrastructure of other stuff. They didn't have to write new libraries. All of that was completely available because C++ was just translating into C.
That was done in '83, and it's a real compiler. It did lexical analysis, syntax analysis, type checking, generating a tree representation, and then did optimizations on that tree.
A lot of the input to the design of C with classes and later C++ came from people dealing with systems programming, dealing with distributed systems.
I guess one thing that is mildly interesting is the question, where did the name C++ come from? CFront, not very useful, and that's an implementation. C with classes, a bit dated.
So I asked my friends to make suggestions, and I got a list of about 20-25 suggested names. And then I sort of liked C++. It was a bit weird as a name, but makes semantic sense.
Because the ++ operator is part of the C programming language. It basically means increment. And so C++ is an increment on C.
It really should have been called ++C for semantic reasons, but I took pity on people doing indexes and referring to it, so it became C++.
AT&T's famous Bell Labs in New Jersey, home of countless technological innovations, but mostly in the field of communications. For up until last year, AT&T was the phone company. But now with deregulation and divestiture, AT&T is free to move into other ventures. And one of its first and biggest new ventures is the move into computers.
AT&T decided that they were going to be in the software business. And this was, I think, one of the truly dumb ideas of the company, but that's okay.
Today, AT&T offers an entire family of computers based on leading-edge technology.
One of the things they were going to do was to sell a C++ compiler.
And in the days we're talking about, things like compilers were piggybacked along with hardware. You got your compiler from IBM, you got your compiler from HP, you got your compiler from Sun, you would get your AT&T hardware compiler from AT&T.
There were a few companies that were actually genuinely interested in and paid for C++ compiler, and there was a development group which worked on call it an industrial strength or production quality C++ compiler.
That didn't work too well because they couldn't actually deliver a good compiler. There was only 14 of them, but I got peace and quiet to do my work.
The hardware didn't sell well enough, so a lot of that software ended up not being ever commercially viable.
And that was what allowed me to basically give away early implementations of C++. They weren't free, you had to pay for the tape it was on. And if you had a commercial use of it, they wanted some money too, but not very much.
I'd like to tell a bit about C++, why the language looks like it does, and present some of the main techniques that the language was designed to support.
I was giving a talk for Bell Labs for a movie. They wanted me to read out from a prompter. And a third of the way into the talk, the prompter broke down. But I really didn't like it, so I carried on blind for the next 2/3. And each time I had to think about what to say, I grabbed up and pulled the bird to give me time to think about what to say next. And so that video became known as the goose video. And this is it. At that time, I was doing the documentation, I was doing the compiler, I was doing the language implementation, and I was the help desk. Having all of these worlds in the air at the same time led to significant improvements.
Bjarne designed the language to make programming more pleasant for the serious programmer. I always thought it was professional. I went and looked it up. It's in the preface to his first edition of the book. C++ allows you to think abstractly about the problem that you're trying to solve. You don't have to think about what's the computer doing all the time. And you get performance that is commensurate with, not identical, but commensurate with languages like C. It really did make programming more fun because you could get more done more quickly.
As CFront became more popular, it became necessary to have a user interface organization so that Bjarne didn't have to send out compilers to everyone and fix every bug that got reported and deal with everything himself.
It wasn't getting any investment, by the way. No. On language proper or on the compiler, there were, maybe 5 people. Not a major investment for AT&T. No, it was a very small effort. Originally, it was literally one person. Bjarne was everything.
We should have had a bigger team, but we never did. Because I think AT&T just really didn't know what they were doing. And at the time, we were all, why don't they give us the staff we need? In retrospect, as a sort of more mature, not in the middle of it, they were all so lost themselves. They're just figuring out how to be in the competitive world. And they didn't do a very good job of it.
Actually, AT&T did give me some money once to do some organization, $5,000 to be used over 3 years for popularizing a general purpose programming language. Doesn't make any sense. I gave a party at the first C++ conference. That was it.
When I think back over our years of C++, I always thought it would be successful because people had this response to C++ that made it seem like they wanted to use this language. And it just was a matter of growing as the community grew and adding new applications as libraries were made available. It wasn't an overnight success.
Yeah, it was not an overnight success. I remember Bjarne once said, being an overnight success takes decades.
Right, right.
Andy and Barbara did something that really good developers rarely did in those days. They tested.
It was a buggy product for a long time.
We were making a release.
2.0 was a huge release. It was intended to fix some of the long-standing reliability and just plain old bug issues that the compiler had. But it was really going to be the commercial release.
After CFront 2.0 was shipped, I discovered that there was a bug in how it handled multiple inheritance. So we had this horrible problem that there was a major feature that we had promised, come on, there we go, that we were delivering for the first time and was broken in a way that if it got out into the field, it would never be possible to fix it.
Compatibility in a programming language is crucially important. Once people have existing code, they don't want to have to change the code just because you found you wanted to change something in the language. So we used to joke about compatibility was the C word because it was dominant.
This was just a completely horrendous state of affairs, totally unacceptable. We were able to scramble a fix in a few days.
Our software distributed at the time out of a tape library. We sent them a tape, they duplicated the tape, and then they distributed it to the customers.
But then we had to deal with the problem of what today is called slipstreaming. Every once in a while, someone will ship a system that's just completely broken and they'll come out with a new one and give it the same release number, and now all of a sudden someone files a bug report, you ask which version they're running, and they say, oh, we're running version 2.0. And you ask, was this version 2.0 or version 2.0? The one shipped before such and such a date or the one shipped after? Well, how do I tell?
Well, of course, a tape has a label so that you can tell one release from another release. Well, we couldn't call it 2.01 because that would be egg on our faces. We couldn't even get the first release out.
So instead of shipping version 2.0, we shipped version 2.00.
Which we all affectionately referred to as 2.00.
That was probably one of the tensest technical problems that we came up on, because if that had gotten out there, then I don't know what we would have done.
Uh-oh.
C++ had kind of a bifurcated existence within AT&T's overall corporate world. A huge part of the support for C++ came from internal development groups. And in fact, a huge reason C++ was ever given the resources, minimal as they were, was because management understood that it would make programmers inside AT&T much more productive themselves. They'd write better code faster with smaller teams. What's not to like? But a programming language is never going to be successful if it's captive to a single corporation. Programmers wouldn't come in knowing the language. We would be the only ones writing the software itself, developing libraries, all kinds of overheads. So it had to be external as well as internal.
People were starting using it outside, but it was quite small.
This is well before the web existed, but there was this thing called Usenet. Usenet is a sort of a glorified bulk email system. There was a whole category of groups for programming languages, comp.lang.c, comp.lang.c++, comp.lang.fortran, etc. So that's certainly one way in which information got around.
There was a huge community of computer magazines at the time. There was in particular one called Byte Magazine, which, I mean, it was literally the size of a phone book. That was the Bible. That was the source of knowledge.
And C++ was in the magazines. We would see that and we're like, we ought to try that sometime.
What I have here is an issue of the Danish PC World magazine from February of 1989. Here's this article with Bjarne and I look like I'm fresh out of high school, which is not half untrue. I think I was 28 years old.
One great thing that Bjarne has done back then in the late 80s was to give talks at any company and any organization that would have him. And he relentlessly worked on proselytizing the language. That was a very successful campaign on his side.
We saw this use of C++ going up like that. And the thing I'm somewhat proud of was there was no advertising campaign. No sugar daddy trying to push this out in the world. It just spread.
The fact that there was this notion that you had data together with functions and a whole new way of thinking about programs and programming, all of that was enabled by C++, to be honest. And back in the 90s, it was so much emulation and so much energy and so much enthusiasm about the language.
writing C++ applications. The design and evolution of C++.
C with classes and later with C++.
C++. C++. C++.
C++.
C++. C++ code.
C++.
The downside is that C++ was all over the place. There's different implementations, there's different standards, things were really incompatible.
There were multiple implementations of C++, right? Many in the early times.
Borland wanted one, Microsoft wanted one, IBM wanted one, Sun wanted one, and they just built it.
Each vendor started implementing their idea of templates in particular, and they were pretty divergent. They worked in different ways, and they had different strengths and weaknesses, different trade-offs because of design choices, but they weren't compatible.
Every company would say, I will make it better, and things will diverge. So if you write code for one, it wouldn't compile on the other. There will be terrible, terrible situation, and eventually the language will collapse.
Obviously, there's a strong desire for there to be compatibility between them.
One day, a couple of people turns up in my office and say they represent IBM, HP, and Sun, which are the three biggest computer manufacturers and software deliverers in the world at the time. They basically said, Bjarne, you want to standardize C++ under the ANSI rules, the American National Standard, later became ISO.
A standard is a contract between a person writing C++ code and an implementation of C++. So when you write a certain piece of code, you have a guarantee that it will do whatever the contract, i.e. standard, says.
Obviously, I said, no, I can't do that. It's too early. I'm doing all of these experiments, and it's not ready. No, Bjarne, you don't get it. You're going to do that because otherwise we will do it, and you know we're going to mess up. Oh. And this went on for about an hour, and basically twisting my arm. Ow, ow, ow. And they're saying things like, of course we trust you, but we can't trust AT&T. Sometimes we compete with AT&T.
Yes, he was forced, but it was something which is actually very good for the language and for him and for the world. The standards are not necessarily good or correct, but they're standards. Is why do we need traffic laws? Traffic laws are very often idiotic, but we have to obey them, otherwise we will die.
And so in the end it says, yes, okay, I'll help standardize C++ under ANSI rules. Just give me 1 year before we start that, because I have to write the document that was the foundation of the standardization.
Bjarne shipped the annotated reference manual, what we call the ARM, ARM. This was sort of the input into the standardization effort, which were to add templates, exceptions, and namespaces, things like that.
And shortly thereafter, there was an ISO standards committee established.
Clearly, standardization is not easy. People have to agree, and it's especially difficult because the language is still evolving.
At the time, the standards committee was almost manageable. There was only about 100, 120 people involved from all over the world and all the major companies.
This is a collection of pretty much random people. Many of people who represent countries just nominate themselves. The guy who represented Australia also represented New Zealand, because he wrote them a letter saying, I represent Australia, I have to travel there anyways. I could represent you guys. And they said, oh yeah, fine, good, we'll have representatives there. So he had two voices. He could outvote United States.
I believe it was Winston Churchill saying that democracy is the worst way to organize a country except for all the others. There's value in having a consensus, especially when it's something that now multiple vendors have to agree on and implement.
The standards committee was happily going on. And then along comes this firebrand named Alex Stepanov. A dozen of us were at a tapas restaurant, not a topless restaurant, a tapas restaurant. Alex gestures to one of the servers and says, "I would like 4 bottles of red wine, please."
Stella.
1 for all these people and the other 3 for me. It cracked up everybody at the table. That memory really represents Alex for me, just a guy of immense enthusiasm and verve.
The STL, the Standard Template Library, was one of these major inventions from Alex Stepanov.
C++ did not yet have a standard library.
Before STL, everybody had their own array class and their own list and their own trees and containers and algorithms and ways to do things and whatnot. They were competing at this level of nirvana, right? And they're all comparable to each other, and it was unclear which is better. And STL came at 10,000 meters. And everybody here we can't compete because we're in a different, not in a different category, in a different game, okay? Much inferior.
I realized that algorithms are affiliated somehow with mathematical theories.
His thing was to design runtime libraries that would make it possible to reason formally about data structures in programs.
The central idea of STL is to write algorithms which will work on all applicable data structures and assure that every data structure could populate any other data structure.
We talked at some point about what he had accomplished and what this library looked like. And I thought, this is something that's completely revolutionary. Maybe we should be rethinking what we're going to do. And I spoke to a few people about that and was told, well, you have a timetable. It's really too late. We can't do anything about it. So what I thought was, well, the one thing I can do is to make sure that Alex gets a fair hearing. I know we have a timetable, but I want you to hear what this guy has to say.
So I gave a talk entitled The Science of C++ Programming. I don't think anybody actually understood what I was saying, but it was very well received.
The committee said, we're way too late in the cycle. This is way too big a proposal. Look at this. Wow, this is pretty good stuff. We really need this.
He gave such an electrifying presentation. It was just so brilliant.
I got a standing ovation once in my lifetime.
He's a splendid rabble-rouser. When he's into some idea, he can explain it very well.
And then Andrew sent me a message saying, why don't you submit a proposal for standard library in C++? I answered, Andy, you're crazy, because I thought that the chances of it being successful were 0. But my collaborator, Meng Lee, convinced me that instead of wasting my life gossiping around, I would do much better if I try. Amazingly enough, it was not rejected offhand. And at that point, I have to say that Bjarne, who still didn't quite understand what I was trying to do, but he became convinced that it was a very promising direction. I could use the same algorithm for reducing n elements together into one. And then I realized one very, very simple thing. The fact is that both plus and times and min and max are associative.
It looked really weird, I thought, but over the years I built up a list of criteria for what would make a good foundational library, and when I checked this weird stuff that I got from Alex, it checked, I think, 11 out of 12 of my points. No other library design I'd seen could do that.
And he started working with me very closely.
My contribution was partly to curb over-enthusiasm from Alex, partly to provide the language facilities that allowed him to do what he wanted to do.
To a great degree, this part was a collaboration of Bjarne as a language designer and me as an algorithms and data structures guy.
And then convincing the committee took a lot of discussion and examples.
We resubmitted a revised proposal. We didn't believe it would succeed because all the powerful companies such as Microsoft, at that time the dominant company in software, were very opposed to it.
The committee was convinced it was too complicated and too difficult to implement.
I have to give great credit to Bjarne. People would say, oh, I want such and such function, and he would tell me, oh, put such and such function there, and he was very successful. And I don't think that STL would become a success without his support. They voted, like I think 80% of the committee suddenly voted for it. Of course, Microsoft didn't, and other major players in the library world voted against, but they were minority, and STL became part of the standard.
When I first saw the STL in 1994, it blew my mind. It was order in chaos. It was rigor in a mess. The STL came and established the one way to define algorithms, the one way to define containers, the one way, and it was superior in so many ways and so absolutely visibly, undeniably. Essentially, everybody was like, well, we better get with the program.
The reception of STL was quite enthusiastic. It's not that people knew what to do with it, nor did they quite understood how it worked, but it was enthusiastic. It was new, it was very unusual at that time.
Oh, I think that it has had at least as much of an effect on how people program as the existence of C++ itself.
I immediately thought, this is huge for C++. This is going to carry C++ into the next millennium, and it did.
Let's see if I can find it. The words that we came up with were Studebaker and vivisectionist. And so the idea is you try to get those words into the discussion, and you get extra points if you can get them both into the same paragraph without people suspecting. And Bjarne said, well, let's see if we can get those into the standard. And you'll find those there. And not to be outdone, I said, well, let's see if I can get a limerick into the description. And it's in here somewhere. Let me see if I can find it. It'd be page 201. When writing a specialization, be careful about its location, or to make it compile will be such a trial as to kindle its self-immolation. Studebaker and vivisectionist. Those were the code words. Those were the words that we had to try to get into the standard somewhere.
Nobody independently noticed it that you know of, did they?
Not that I know of.
Who's reading that?
It's really buried. It's really buried.
C++ got standardized in November 1997.
Where we added several major fundamental features, namespaces, exceptions, templates, and the standard template library.
LLVM was really fortunate to start after that. What we could do is we could say, okay, well, this is the language as it's supposed to be now. We didn't have the compatibility problems. We didn't have to migrate old code. Instead, we could just use the new features and use the language as it was intended to be used.
The people who came to me and said they wanted standardization were very right.
I think it was a huge contributor to the success of the language. No standardization would have meant the language would have forever been like the Wild West. Serious companies would not have adopted it for their use.
CERN is an international organization funded by its member states, and C++ has been in use here at CERN from at least the early 90s. In high-energy physics, software, and computing, which is the field I'm most expert of, C++ was a real paradigm shift. Before, the language was Fortran, and it did a quite quite of a good job. I mean, the results are there to testify this. But when C++ was on the rise, I think at the beginning of the 90s, then people realized that the language really offered many assets. And lots of libraries and existing code was ported to C++ and even reinvented for C++ because the paradigms behind the two languages are totally different.
They have data analysis software, process control software, and visualization software. And all of that plays straight into C++'s strength.
It was spreading by itself. Some company tries it, then the next company tries it. By, say, 2000, it was everywhere.
In game development, a lot of people were aware of C++. There's already video cards now taking care of like that low-level stuff, so it kind of pulls people from C and assembly up to C++ and APIs. There was like a focus change there. So I run the game on the PC and develop it for in Unreal. Everything else is always in Mac OS. C++ is really great for games because of how you can organize everything in your game. And C++ does a lot more than that, but in game dev, people kind of restrict themselves to that, so they have full control over the amount of time that's being spent, per cycle. You have to have all the cycles you can. Don't jump into the runtime.
It was used early on, surprisingly, in the financial industry. Wall Street was just getting into doing program trading and having computerized support for the traders.
Rewind to the late 90s, early 2000s, what does trading look like? You imagine like sort of pit traders yelling at each other, having a human in the loop clicking a button to ensure a trade gets executed. It was very inefficient.
Some economists think the days of face-to-face trading are numbered.
It's known as high-frequency trading.
And it was the web culture taking over what the stock exchanges had done.
So HRT was founded with the idea of like, okay, there's really some automation that can happen here.
Little differences in performance can make big differences in economic viability. And therefore, performance matters in many cases more than you might think.
Latency is really important in trading. Microseconds matter in this space, and C++ is a language that lets you achieve that latency without really needing to micro-optimize every line of code.
I'll use a quote from my friend Scott Myers. C++ is for demanding programming problems. I still have abstraction, but I can make full use of hardware. And it turns out that lights up a lot of different industries.
It's described as nothing short of breathtaking, a points drop never before seen on the US markets.
2000 came, the dot-com crashed, and with it a lot of the tech companies and the tech industry. But also there was like the growth of Java.
This week on the Computer Chronicles, the secrets of Java. Today we're going to find out why Java, the software programming language, is such a big deal.
Java came very heavily marketed by Sun Microsystems as the language of the future and the language of the internet.
What will be possible tomorrow? You decide, because Java is everywhere.
There was executives for Sun that was going around saying Java will kill C++, absolutely kill C++ in 2 years.
I remember I had managers who were like, I'm not sure what it is exactly, but we gotta get into this Java stuff because it's awesome and everybody loves it and that kind of stuff.
Java is an explicit reaction to the complexity of C++, the perceived complexity at least, and so Java was an attempt to get some of the same benefits that you get, particularly from object-oriented programming, but in a form that was not so complicated.
That was not favorable for C++, and that combination of events ignited, or started, if you wish, the C++ winter of the early 2000s.
It was not just stagnation that happened around 2000, 2005. It was decline.
There was one more factor that contributed, which was the computers were getting faster at an exponential rate.
Computers started temporarily being more powerful than the software being run, especially on single-threaded code.
Right now, it's hard to imagine that you would have a processor that doubles the frequency every couple of years, but that was the case back then.
We just thought, oh yeah, computing's just going to be getting faster and faster indefinitely. We better write bloated operating systems and stuff so that to soak up the power. Like this was actually a way some people thought.
Most people who design programming languages, and especially back then, says performance doesn't matter. Machines are getting so fast. We'll just wait a year and then it'll be fast enough.
So this combination of factors led to a sort of an exuberance of inefficient programming languages that played out poorly for C++.
At that time, at Microsoft, we really had two distinct groups of programmers. We had the C++ programmers, and that was all about power and expressiveness. And then we had an enormous cohort of Visual Basic programmers, which was a very different crowd, you know, because we were talking about rapid application development. You had like a form designer where you could just drag and drop buttons and text boxes. And a lot of enterprise-y software was being built with that. But when it came time to deploy it, you kind of wanted better performance. So we were seeing this phenomenon of people like writing the app twice. First, they prototyped it in Visual Basic, and then when it came time to actually deploy it, they would go rewrite it with a different set of programmers in C++, with a different framework, you know, like for your windowing system. And it was not a super efficient way of getting to your software. So there was this sort of latent desire to have a language that had the ease of use of Visual Basic, but the power and expressiveness of C++. And that's what we set out to build with C#.
There's no shortage of people telling me that I should be afraid.
I can't really count the number of times I hear comments like, oh, you mean C++ is still being used? Or why would you want to use C++? A lot of this talk of C++ is dying a slow death.
I'm famously not a huge fan of C++.
We got Java, which is basically just a better C++.
Is C++ dying?
Everyone wants it to be a war. It was never a war, I don't think.
People think that every language designer wants their programming language to be the one and only. To me, that seemed a very strange, weird, and arrogant view.
Programming languages in general, they're tools that allowed us programmers, developers, to express our ideas in a way that a machine can execute. So understandably, people get strong opinions about how you're telling them to express their ideas.
It does become religious for a lot of people, yes.
I never had this idea that C++ should be the only language, or that it could be the best language for everybody and everything. I don't think any language can do that.
Every language that is successful in the world today has its place and is there for a reason and is affinitized with a certain kind of programming. Yes, there's a bit of overlap between C++ and C#, but it's not all that large. And so it isn't really a war. It's more of a complementary situation. You know, we serve different communities. And sure, you could try to write your enterprise apps in C++ and have your enterprise programmers worry about memory management and, and dangling pointers or whatever. Or you could try to write operating systems, low-level embedded systems in C#, but they're poor fits for that. There's a right place for everything.
And, well, most Java compilers are C++, so.
2004, something abruptly came to an end, which is the frequency scaling of processors.
Around that time, I started hearing rumblings from senior architects at work at Microsoft who were noticing hardware starting to slow down. There's diminishing returns. They're not able to ramp up the instruction level parallelism as much anymore. They're starting to hit the performance per watt limits of a single core. For the first time in 50 years, which is the whole history of computing, mainstream hardware is no longer a von Neumann machine. Everything is changing underneath us. And a lot of people, I think, are still ignoring the impact of that. Everything is pointing to that the world is going parallel. And I started realizing, well, this doesn't seem to be something I read about in the magazines. I should probably write something about this.
If you wanted to have your programs run faster, you couldn't just wait for a year and have the hardware save you.
Which meant C++ was, again, a good offer in town for an efficient programming language.
That and that C++ was now good enough to be used in embedded systems. There's many more embedded systems than there are sort of computers with screens like that. I mean, we have 2 of them sitting right there.
So after 2004, there was an increase in adoption of C++. But there was an odd factor which, in my opinion, contributed to the stagnation of the language during that time, which was the leadership of C++ was complacent. And I wrote an email that became famous of sorts, which title was, C++ multi-threading, is the standardization committee listening? And it was about multiple threads because multiple CPUs were coming out, and the threading was a way to make programs go faster, but C++ had nothing about threading at the time. Didn't even mention it in the standard.
We wanted to deal with concurrency, and we wanted to adopt something that was rather similar to Java's model. It got de facto vetoed by IBM and CERN because they pointed out that if we ran that way, their Java implementations would halve in speed because they couldn't use all the interesting dirty tricks they were doing with C++. We actually had to work for another 2 years coming up with something that was more advanced, more complicated.
You need to have the tools that allow developers to write very quickly, to express the ideas, to get their stuff done. And for a long time, C++ didn't have that kind of tooling.
Herb was the one who said, we gotta create a new standard, address multi-threading, address these issues in the language. And that changed everything.
Andrei! Hey, how you doing? Are you all ready for tonight?
I will.
Oh, good.
I was born ready.
I know you were. I know you were. Hey, good to see you.
Hi.
Looking forward to your keynote, by the way.
Thank you.
Hey, Matt, good to see you. ISO calls the role that I've had the convener.
The convener.
The role of the convener is to convene meetings, say when and where we're going to meet, it's administrative, and to get consensus. Consensus does not mean unanimity. It means everybody has been heard, and then the committee makes a decision that everybody can live with. And so in 2002, we started work on C++ OX because it was intended to ship in like 07, 08, 09, somewhere around there. Currently, the goal is that X is not hex, and that we're going to be done next year in 2008.
It took 13 years because when you get close to the release, people say this feature is so important, you must delay the standard to get this feature in. And then you delay the standard, and then somebody else comes with a new facility that really should be pushed.
Herb really pushed C++ from complacency to literally to where it is today.
I just started talking to the main subgroup chairs and said, like, why are we delaying? The community is wondering if we're ever going to ship a standard again, because we already are several years over. We don't need to wait another 2 years. Aren't we ready to ship this now? And enough people said, you know what? Yeah, I guess we're ready to ship this now.
Herb's a great guy. You need different kind of people to do different things. For starting, he's much better organized than I am.
One of the things that Herb did was to also popularize the work that the committee is doing.
When C++11 did ship, a few years later than we thought, but then did ship, it was at a great moment in time because at the same time as the standard made C++ much easier to use and safer than it had been before, there was a renewed realization of getting the most out of our hardware, which is what C++ is good at. That was a real renaissance moment.
11 is completely different. Yeah, they share syntax, but the way you think about problems is very, very different.
With 13 years from the first to the second standard, there's a lot of new stuff coming in.
We had move semantics, we had concurrency, was work by Hans Bohm and his friends. That was the first language in the C family that formally said something about threading. If you only took those two, it's already big.
At the time here at CERN, we were evolving our data processing frameworks that relied on event parallelism into something that was more suited for the multi-core CPUs that were appearing on the market and became the de facto standard. And having the obligation to rethink our way of processing data with parallelism at its foundation was easier thanks to the tools that C++ provided out of the box to us.
Things like auto range-based for loops, smart pointers.
That lambda was cool when you added that, but the garbage collection was not cool when you added that.
It also started the whole context growth thing, which is a way of getting certain kinds of evaluation done at compile time in a way that's easily expressible in the language.
These are all things that were like a major refreshing upgrade, where it's still C++, but man, it feels like I'm writing a new language.
Maybe I should dust off my C++ coding skills again and take a look at it again and put that C# in the drawer for a while.
You use the right tool for the right job.
After that, we had lots of discussions, and I spent about 2 years trying to convince the committee, we really should go to time-based releases.
Referred to as the train model. The train leaves at the station at this time. If you don't make that train, you don't stop the train, you wait for the next train to leave the station.
That way, the whole industry knows we're going to release, and we never go dark again where they wonder if we're ever going to release a standard again. If I'd had my way, we would have shipped every 2 years. The committee said, no, that's too often, let's do every 3 years. And I was happy to take that as a win.
If you're still stuck in 98, either mindset or compilers, upgrade. It's the best way of getting ready for the future. Is actually at least get to the present.
C++14 was a minor kind of bug fixes release.
It basically put in place the things we couldn't get into 11.
And today I'm going to be talking about C++ 17. These are the 26 features we're going to be talking about today. So this is
on one hand, I think that C++ 17 was like a really high peak in terms of the capabilities it enabled. But ever since then, they've been adding more features.
So let's have a look at the agenda for today. There's quite a lot. So I'll be giving an overview of all the new language and standard library features coming with C++ 23.
There's a huge community and a huge committee of people that are adding new things to C++. And so one of the big questions that C++ has to wrestle with today is like, where does it end?
The way C++ has evolved was by essentially like, we have this language, we add something on top of what's existing, and that's your new armor that you're gonna roll with, right? And on top of that, there's more and more and more and more.
How did you manage to add this many things to the language and 99% of them are critically broken? It's almost like a winning streak. Well, I guess it's a losing streak.
C++ is absolutely atrocious. First of all, there's like 20 different ways to initialize a variable. It's an infinite Gordian knot of unfathomable complexity.
C++ was always a fairly complex language, and it has only gotten more complex over time, and this is not unknown. And that, I think, is the challenge, right?
The Standards Committee now is an organization with lots of people. Last time I checked, there was 527 members. How you get 527 members to agree on something, I don't know.
We have as many committees and committee chairs as we had members when we started. And this worries me.
I had one person describe the committee as the real housewives of C++. Do you agree with that?
Whenever you get lots of people discussing things that they're very passionate about, you're going to get a lot of conflict. I think if we didn't have any drama, that we wouldn't have people that actually care about what they're doing.
One of the problems with committees is that you have a tragedy of the commons. It's very easy, relatively speaking, for people to add things. And so it's not that any one of these ideas is bad, but adding more and more and more and more and more conceptually is bad.
You kind of have to find a balance between having too many opinions and also having opinions that represent the community well. We do the best that we can, really. I think we're constantly trying to bring in more knowledge, more people, more experience. But yeah, with that, you simply get more people and it becomes even harder to agree on any given thing.
I'm fairly optimistic still. There's a lot of really smart people working on C++. I think that the intentions are good, but this is one of the challenges that the C++ community struggles with.
In a lot of ways, it becomes a game of knowing when to say no. There's no shortage of things you can add to a language, but one thing you learn as a language designer, you can add, but you can never take away.
Welcome to a session that I did not know I was going to give until I foolishly volunteered about a week ago. Any improvement that you make in a language like C++ has an outsized impact on the world, an outsized benefit to our society and civilization, because so much of our infrastructure is built on C++.
We can go and have a look at some of the stuff they're building. Because one of the reasons I go is to see what people do with the language. And everything here has C++ somewhere, quite often well hidden underneath everything else. That includes JavaScript and Python and things like that.
I was asked recently about where C++ was used. The simplest and most accurate answer is roughly everywhere. It touches most people on Earth, or at least half of the people on Earth, every day.
Would you want to try the VR, or?
Sure.
It's in your camera there, it's in the electricity generation, wind turbines, rice cookers, bowling alleys, Hollywood movies, cars, finance. It's all over the place.
So, whoa! So it's gonna be a different world right now.
Oh, I see. The steering wheel is in the wrong place.
On with the touch screen, if you want to, like. Yeah.
Last time I tried this, I got burned by smoke.
Okay.
You have to interact with people. You can't do language design, language development just in isolation. If you do it in isolation, that's how you come to solve the wrong problems, and that's useless or worse.
To give a sense of the scale of HRT's C++ footprint, we currently have over 1 million lines of C++ code in our code base across 15,000 files. Our repository has had about 84,000 commits just this year, 2025 alone, across around 800 developers that are actively contributing.
For games nowadays, C++ is kind of divided by the ecosystem that you're working in. So right now, there's a lot of different game engines, and the game engines are basically what dictate the language that programmers are using. There's Unity, which is C#, and then there's Unreal, which is C++. And if you're making anything like Call of Duty or anything that is like high frame rate, super fast graphics, you're using C++ no matter what. It's for speed, that's why.
A lot of people are interested in contracts, but there are two groups with very strong opinions about it. There are many
C++ is very relevant to Nvidia, is very relevant to accelerated computing. Even though Python is the language that is experienced at the surface of most of these applications, what happens is that the very second you build your Python program, it's going to tap into these enormously optimized CUDA libraries that are going to carry the burden of computation. So in an interesting way, C++ powers the entire AI and high-performance computing milieu.
What are the fastest growing programming languages? Rust and C++.
C++ has climbed from 9.4 million developers in 2022 to 16.3 in 2025.
It is because we have enduring demand for languages that are good at performance per watt.
What is certain is that C++ found its a set of use cases where it's excellent and hard to beat.
It's probably the most widely available programming language anywhere.
As the challenges in our industry and our environment change over time, all languages have to adapt.
One thing that I see as a danger to C++ is the lack of funding. From what I'm seeing, a lot of the big players are moving away from C++ into AI. It means that we're going to have even less funding. So I think that's one of the issues, and we need to somehow pull in people with the money to come and give it to C++ in one way, shape or form.
I would argue that right now we're talking about the second winter of C++ because there's a safety issue that's very important right now.
It's a real serious problem. I really don't want my brakes not to work when I press it if I had a car.
There has been a push during the pandemic from various governments and regulatory bodies to move away from C++ because it didn't produce memory safety by default. It is the singlest most important problem that we need to address effectively.
A huge amount of work has been done and is ongoing. We have been hardening our software.
In C++26, it's motivated us to where we've actually gone and done important things, such as uninitialized variables are no longer undefined behavior. That entire source of security vulnerabilities is gone. If you build with the C++26 standard library, you have an option for bound safety for all the common types in the standard library. String, span, vector, all those things.
I think AI is going to influence a lot what we think about safety in languages and generally what we think and how we think about using programming languages. Of course, there's a lot of opinions, but right now I can safely say nobody knows what's going to happen.
So on Saturday, the world changed, and we are going to look back on that day, this past weekend, for the next few decades as a pivotal turning point for C++.
C++26 looks like a Christmas tree. Has a bunch of things for a lot of people to be excited about.
Something called static reflection is going to make some major improvements.
You can write program code that can see program code.
Reflection is by far the most impactful single feature we have ever standardized.
It's more of like a foot in the door than a full-fledged feature, but in my opinion, people are going to do amazing things with it.
It seems like a really powerful paradigm that we think will go a long way once the features are fully rolled out.
Our problems and our understanding of those problems naturally change over time. And as long as a language is a good solution to problems that are faced by real programmers in real code, the language will live and the language will grow to meet the needs of the programmers.
Knowing the language as I do, I would say that there's going to be a way in which the language is going to again evolve and change and improve and do better. But that's only up to the people who are involved in the language.
Gabby explains the code by equations, and I do data flow diagrams. So we definitely think very differently, and that's one of the really productive aspects of it.
the thing that I love the most about collaborating with Bjarne. Whichever way it goes, whether we succeed or fail, I learn something.
There's no other people like Bjarne, in my opinion. Nobody who could spend literally his life. Such commitment is not known. I very much hope that Bjarne would be more recognized than he is right now.
I can only admire his devotion to the project. I mean, what has he been involved for more than 40 years now, and he's still the benevolent dictator for life, right? That's an incredible run.
He proved you can do efficient abstraction at scale in the same way horizontally in portable code. We are all benefiting from that because we wouldn't have so much of the technology we have today if we didn't have a way to write much larger efficient software than we could with C.
What keeps me going is the interest in the applications and talking to people who built them. I've launched this thing on the world and I feel I'm obliged to help make it better, more appropriate, and help users. And the world changes, and what developers and students know changes, and so you have to do some more. That's what keeps me going.